So how to improve security for open fronthaul for terrestrial, non-terrestrial. So we have another security, but this is a little bit more focused and also includes non-terrestrial networks, which is also interesting. So Alessandro is an adjunct professor, and let me introduce Alessandro here. So Alessandro Vizzarri is an adjunct professor at University of Rome and Tor Vergata, where he has been teaching radio spectrum management since November 2011. He's also a project manager at Radio Labs, managing research projects in telecom field since 2014, and professor at 24-hour business school, teaching digital strategy and e-commerce post-diploma. Previously, he held positions and technical director at GM Service Branch, executive manager at Net Engineering. He holds a PhD in telecom and microelectronics from University of Rome, where he is currently affiliated, and degree in electronic from alma mater Studio Rome, Bologna. Oh, that's a nice place. Notable projects include Logon Logistics Open Network, distributed architecture, home modular, multifunctional system. So Alessandro, is all yours. You have 20-minute presentation, then 5 minutes discussion. Thank you.
Okay.
Let's take it over. Yeah.
Thank you, Professor. Can you see my screen?
Wait, have you started sharing? We just see my screen here. Okay, just hold on, it's coming up. Yeah.
Yes, we see it, yes.
Yeah, now it's coming up, yeah, please.
Okay, thank you very much, Professor, for the invitation to be here. I would like to comment a few slides in order to have a very short presentation about this this topic. I would like to talk about the possibility to improve, to understand which kind of solutions we can implement about the security of open fronthaul for terrestrial and non-terrestrial networks. First of all, I would like to mention the vision we are going analyzed in several 6G research projects, such as this one, and together with the Network 2030 vision. We will have a strong convergence between terrestrial and non-terrestrial networks in terms of satellite networks, drones, hubs, and so on. We will have smart intelligent communication networks thanks to artificial intelligence techniques. We are going to move to provide intelligence applications, methodologies at the edge of the networks in a closer position to the end user. So it means that we will have several nodes, several communication nodes, both for access, for heterogeneous access, terrestrial and non-terrestrial networks, and also the integration of these networks and all of these applications is very important for the success of the next 6G. Also in the context of beyond 5G, but especially with 6G. Moving to the Open RAN reference architecture, we can see that in these slides, moving from the left to the right, we have three main components in the RAN segment. We will have the radio unit, Open Radio Unit, ORU, decentralized unit, and the centralized unit. These three main components are, according to the disaggregation model by the 3GPP, are separated in terms of software and hardware. So we assisted to a decoupling of software and hardware. We have seen a strong vision of softwareization, and the next step made by the Open RAN is to provide open interfaces between these three main groups of nodes: radio unit, decentralized unit, and centralized unit. Since we have three main categories of network nodes, we can call open fronthaul the segment linking the radio unit and the centralized unit, the midhaul from decentralized unit and centralized unit, and finally the backhaul from the centralized unit and the core network. In these three segments, in these three links, we have, thanks to the approach of the Open RAN, open interfaces, not proprietary, of course, belonging to the Cloud Run and other industry implementations. And this is the main concept of the reference architecture provided by Open RAN. The same Open RAN approach is based on the functional splitting. The functional splitting, because we are talking about the RAN disaggregation process, it means that all the main functionalities, all the protocol stack standardized by the GPP can be split across these three categories of network nodes according to the choice of the mobile network operator. It means that we will have the situation of the monolithic of radio station, or we have a simple radio unit with only the radio frequency functions, as you can see on the left on these slides. It means that the option, call it option 8, the option where the radio unit is equipped only by the radio frequency unit. At the moment, usually during the industrial development, the split number 7.2x is the most interesting and the most used by the operators, the most splitting used by the operators, because it's the good trade-off between cost and flexibility of this functional splitting. But if you are going on the open Fronthaul, on the link between the radio unit and the decentralized unit, we can see that as we can see in this slide, the Open RAN radio unit uses two interfaces belonging to two different VLANs according to, based on the Ethernet, according to the control user and synchronization plane and management plane. We can have two different models, hierarchical and hybrid, according to the possibility to involve the network management system and the usage of the netconf protocol. It means that also with this vision, with the Open RAN vision, we have the radio unit able to belong to different separate VLANs. It is very important because, as you can see on the left, we need to link these modules, all the sub-modules, and we want to understand how we can secure all these modules linked among them. Also for the management plane, we can see, and this is from a slide from Benetel companies in terms of manual configuration for transport layer establishment for the management plane. Here we can, with the involvement of netconf, it means that thanks to the Open RAN architecture and framework, we have the possibility to configure, to manage, to control the radio unit from the mobile network perspective. In terms of security, recently on the last June, the Open RAN Alliance released a technical report named Open RAN Study on Security for Fronthaul CUS Plane version 1.0 that is focused on security of the Fronthaul. It means that with this release of the new documents, the security features of the Fronthaul, the Open Fronthaul, were enhanced, were deeply discussed. In particular, according to the technical specification by Open RAN Alliance, the MACsec standard, called IEEE 802.1, is recommended to protect both control plane and user plane messages in the Open Fronthaul interfaces. Here we can see several guidelines. The Open RAN interfaces foresees that C plane communications must reach before several messages, for example, and either IEEE 1914.3 or ECPRI is utilized for encapsulation of the control plane messages. This is very important because in this case, for the C plane messages, two layered headers are used. If the first layer is provided by IEEE 1914.3 or ECPRI Common Header. And the second layer is an application layer with fields required for control and synchronization. It means that we have a degree of freedom in order to implement additional features. And in fact, according to the standard, to the MACsec standard, the document recommends that the control information will not be transmitted via enhanced CPRI specific protocol. We can use TCP protocols such as TCP over IP protocol and also other solution. We can consider other solution. It means that if we can consider other solution, we can consider also tunnel protocols at layer 2 and layer 3 for this protocol. For example, layer 2 tunnel protocol L2TP can be used according to IETF RFC 261 can be used for securing the open Fronthaul, and of course can be also combined with the other protocols as I mentioned before for the control plane messages. Thanks to the IPsec, we can add the authentication encryption features of the data, and so we can consider, for example, a joint security solutions constituted by layer 2 tunnel protocol and IPsec. The objective of additional studies, additional researchers can be focused on how we can integrate, we can combine this solution for L2, layer 2 tunnel protocol and IPsec in order to contribute and for improving the security of control plane user plane within an Open RAN framework. In order to, for example, to enhance to find an enhanced solution for MACsec or to integrate MACsec protocol with a layer 2 tunnel protocol with IPsec. In this slide, I only collected a couple of security issues about 3 different planes. This one is key issues. Number 1, at synchronization plane, focusing on impersonation of a master clock with spoofing with a time protocol network with a fake announced messages. In this case, we are in the synchronized plane. We are going to secure the announced message from the attacker. And the main problem is that the attacker results in a situation where the attacker clock becomes a grandmaster. This is the most important because the risk, according to the risk analysis made by Open RAN Alliance in the last report, the impact is high and also the likelihood is high. They also listed several security requirements, and as listed in these slides, in order to support, for example, authentication of announced messages and so on, because they are only recommended the MACsec protocol at layer 2. We are talking about Ethernet frames. This is another key issue at synchronization plane in terms of selective interception and removal of PTP timing packets. For example, the attacker can position himself in such a way that allows him to intercept and remove the valid synchronization packets, so we can substitute the synchronization packets with other packets. So we can have also a man-in-the-middle attacker that can be also belong to the intermediate nodes such as TTC, routers and switches and so on. In terms of streets, the Open RAN Alliance identified the selective interception and removal can impact the timing packets, and of course, in this case, removing all packets of random packets, we can push the clocks in attacking nodes into free running mode. This is a second key issue at synchronization plane in order to intercept and remove the timing packets from PTP. In this case, we have a high impact in terms of risk analysis, and also the likelihood is low. And also in this case, the Open RAN Alliance identified some potential security requirements. In these slides, I can put some different configurations about the challenges for deployment in PTP over MACsec. With this scheme, the Open RAN Alliance prepared an effort in order to have a configuration of the different decentralized unit and LLS C1, C2, C3, and C4. So they already made some tentatives in order to overcome, to improve the deployment challenges in a secure way according to the MACsec. If you are talking about user plane, the key issue, for example, here I only put one scenario reported listed in the report. This scenario is at user plane, and the scenario is on the MACsec enabled at decentralized unit and radio unit. So we are going, Open RAN introduces the concept of the tunneled end-to-end MACsec between radio unit and the decentralized unit belonging to different transport network equipment T and E. These two T and E, 1 and 2, are linked through an open Fronthaul, as we can see in the slides. So we have also security challenges here at user plane, and the Open RAN Alliance already prepared some identify some solutions about this according to the recommendation of MACsec protocol. When we talk about the control plane, the Open RAN interfaces, of course, the control plane must be available in order to process, of course, the transmission of packets at user plane. According to the document, the C-plane messages are encapsulated using two-layered header approach, as we saw in the previous slides, and we can see on the right on the slides a kind of protocol stack starting from Ethernet layer 2 and VLAN, IP and UDP are optional, and enhanced CPRI and radio over Ethernet are the protocol used for the control plane messages. As you can see in these slides, the Open RAN Alliance recommend the possibility to avoid the transmission of the control information via the enhanced CPRI specific protocol, and we can use, for example, TCP over IP solution and other. When we are talking about the possible solution for securing Open Fronthaul, as I said before, we can deeply analyze it. For example, the possibility to implement layer 2 tunnel protocol according to IETF RFC 261, where we have a tunnel at layer 2 equipped by IPsec features according to Internet Key Change, IKE, and also the net features. This can be very interesting because we can integrate, for example, the MACsec approach with this tunnel concept in order to overcome the security not only at Ethernet frames, but also we can talk about IP packets. Why we can introduce this concept in the Fronthaul? First of all, because this concept is already implemented in the middle and the backhaul segments. We find IPsec, SSH, and TLS features in these segments. But when we are talking about the Fronthaul, at the moment, as I said before, the Open RAN Alliance recommends the MACsec protocol from IEEE. That the next step should be the study, a deep analysis of the tunneling protocols, the possibility to encapsulate, for example, the MACsec control information within the layer 2 tunnel protocol equipped by IPsec, for example, or we can also talk about the VPN at layer 3. Because if we are including the concept of heterogeneous network, if you are considered that this radio unit can belong on board the drone, or if we can deploy a decentralized unit on board the drone, the open fronthaul should link, for example, two network nodes belonging to different communication operators. So, and also the non-terrestrial network integration can be supported and also secured with this approach. So, because with the next networks with the 6G, we will have small access points such as the Wi-Fi. We will have the radio unit, very small, very light, a huge amount of these equipments deployed in specific areas. So the problem for management, the problem for control, the problem for fault management, and also for increase the capacity and to increase the coverage is very important, and the integration with non-terrestrial network can be very important and also supported by the security features offered by Layer 2 tunnel protocol and IPsec. So I would like only to mention a few words, because MACsec is used for the authentication encryption of traffic at layer 2 within a LAN network, and we are talking about at frames. IPsec combined with layer 2 tunnel protocol is used for layer 3 networks, and IPsec operates on IP packets layer 3, while MACsec operates, as I said before, on Ethernet frames at layer 2. MACsec exposes the user data to every network nodes within the same network, within the same operator, so the integration can be with non-terrestrial networks, from drones, for apps, can be quite difficult. Also for the satellite decoding, for example, connecting decentralized unit and centralized unit. To do that should be, in my opinion, should be interesting to deeply analyze some tunnel-based solutions such as Layer 2 tunnel protocol and IPsec, because these solutions, this one and other solution, can provide a better end-to-end security and high throughput. So we can also overcome the concept of the tunneled and end-to-end MACsec protocol as we saw in the previous slides. We can improve the security, especially in terms of authentication and data integrity. We can improve the required quality of service and quality experience, for example, not only from the security features. And if we have a tunnel-based approach, we can enhance, as I said before, the integration between terrestrial and non-terrestrial network. Also, if we are able to provide these tunnel-based protocols and IPsec, we can also enhance the integration with edge cloud computing that can be deployed, for example, in the central office of the operator, in the same place where the operator will going to deploy the centralized unit. For further study, for next step, for example, can be focused on the usage of MACsec protocols in combination with, as I said before, Layer 2 tunnel protocol and IPsec, or the integration with other VPN protocols such as VPN IPsec, IK version 2, OpenVPN, and WireGuard, that are commercial industrial solutions. And also the possibility to implement, for example, public key infrastructures, a couple of public private keys able to secure the authentication, in particular authentication phase, and also the data integrity. I just finished my slides in order to recover time for the other speakers. I don't know if we have some.
Yeah, we'll have 5 minutes discussion. Absolutely. So I passed it to Alex and Mehmet before I give my comments. Alex and Mehmet, you have any comments on this proposal or presentation?
Okay, I see that you refer to IEEE 1914, the next generation Fronthaul interface. So as far as the the concerns and solutions you provided here, how does it impact that? I don't know the other competing standards competing with 1914, but how does your solutions or your suggestions will impact the 1914? Does it require some updates, or does it require another standard as an add-on to existing 1914? Or it's just something, the Ethernet, because 1914 used Ethernet, right? So the suggestion you're making maybe will just sufficient to add something to the Ethernet that will also, I guess, make the 1914 secure, right? So I'm just trying to understand the impact of your suggestion to existing IEEE standards.
Thank you very much for the question. In my opinion, all these standards, as you correctly said before, are working at Ethernet layer, at Ethernet with Ethernet frames. That standard you mentioned is the radio of Ethernet is able to work on Ethernet frames. In my view, in my vision, I would like to deeply analyze other solutions, enhancement of the same standards, for example, encapsulation, other encapsulation techniques, and then to provide some information and control at layer 3, for example. Because if you are consider this layer 3, if we are going to have in mind that we have a radio unit, decentralized unit, and central unit as different nodes with an IP address, with able to manage IP packet, especially for the control point of view, because as we saw in the list, in the contents of the Open RAN Alliance, they didn't recommend to use enhance the CPRIE for sending message control. They recommend the usage of TCP over IP and other protocols. So we are going to move above the Ethernet layer, the layer 2, and the other standards. So just to summarize, my answer to your question, very interesting question, is that we can imagine to enhancement to provide, to think, to analyze an enhancement of the previous IEEE standards, such as new encapsulation techniques, how we can provide information from Ethernet frames to IP packets, because in my opinion, if we are able to skip to the IP level with IP address, with the IP informations, we are able to integrate. We have a full integration of these 3 different nodes belonging to different vendors, belonging to different communication networks, and then it can also enhance, allow to find new business relationship between different communication networks, for example.
So in the case of 1914, so this could be like, currently they have 1914.3 and .1. So this could be 1914.3.1, for example, right? Is that?
Yeah.
Okay.
It doesn't have to be, right? It can be, if it's on the top, if you don't need any enhancements there and working on the top of it, it can be another standard. But if you do need enhancement within 1914, that may or may not be an issue. But you got to talk to the working group. They may disagree.
I'm not suggesting. Yeah, it is. Of course, you have to talk to them, right? But I'm just trying to understand, Alex. That's all.
Yeah, but easier would be to do it over the top if it's possible at all, right? Because these standards already exist for 4 years, one, and 5 years, 6 years, the other one.
Yeah, this is 2019 versions. So.
That 3 is a year before. I remember this. They finished 3 before they finished 1.
Right, I know.
So I guess, sorry, Alex, Mehmet, are you done with the comments, questions?
I'm done.
Yeah,
Alex?
me too.
All right, so I have a question. I know you talk about frontal, terrestrial, non-terrestrial. So I know non-terrestrial security is also getting very important. Some of the solutions you propose, will this be applicable to non-terrestrial part as well?
Yes, yes, that can be also implemented within a non-terrestrial environment. Yeah.
And do you see any additional consideration there on the NTN side?
You mean the applicability of the IEEE standards to the non-terrestrial network?
Right, right. I mean, what I'm suggesting is, sure, this could be applicable, but on top of that, there may be additional complexity when you think about NTN. That's something, we could look into that. I mean, my personal view is, obviously this is an important issue, but how closely it aligns with 1914 and whether it should be a subset of that, maybe a separate one, because you're adding non-terrestrial aspect too. But the terrestrial, non-terrestrial security is an important area overall. There is a satellite working group within Future Network. I'm just trying to make some linkage here, led by Giovanni. You probably know him. They are looking into some of the architectural aspects of satellite non-terrestrial for 6G and security working group. We have looked a little bit of that, but we haven't really looked into the areas you covered. So these are, if you want to create a task force, folks from these two working groups may potentially join you in this effort. So in terms of next step, Mehmet and Alex, what's your suggestion? Do you think they should just write a little bit extended abstract to make it more clear, define the scope before they really get the PAR thing?
Yeah, I'd like to see the architecture. Like, what are we talking about? If we're talking about enhancement and one thing, maybe Chilean will, or whoever works for her, running the group, agree to it. But maybe not. Maybe you create a new standard and just normatively call 1914,
Yeah, and they are not developing a new protocol per se, then we have to go to ITF, right? I mean, here you're providing a new framework.
Well, it's mingling with TCP/IP, but I don't think Alessandro is proposing to mingle with TCP/IP, just using it.
Right, I mean, not even defining a new security protocol. I don't think they are defining. You're coming up with some kind of a hybrid architecture here, right? Security architecture, I should say. Right? Is that, Alessandro, that's my...
Yes, Professor. Yes. In my vision is the possibility to integrate the existing security features, protocols, and also to think about a possible enhancement, not to define a new security protocol from scratch. The last thing I would like only to mention is that we have also, very well, several IEEE standards about the IPsec features, for example, for the control systems and so on. So if we are talking about IPsec recommendations, features for the Open RAN and for non-terrestrial and terrestrial integration, for example, we can also think about the possibility to identify some features of IPsec, some configurations, like that standard for the control systems, for example. And in my opinion, it is very important not to define, for example, from scratch a new security protocol, but to understand how we can integrate and we can add other features to that.
Oh, that's great. So I think we are converging. What I heard is define the architecture, maybe extend that, put our architecture in the extended white paper, maybe 2-3 page. And so that will help us define the scope, exactly what we need to do.
Right.
And then after that, let's discuss in one of our monthly meetings. So I'll schedule one. And then in the same time, I'll send the PAR form, so at least you can start filling out that. When the architecture is defined, we'll just run it through Alex and Mehmet, and review the PAR. Will that work for you?
Yes, Professor. I mean, please consider me fully available for this.
Oh,
Perfect.
excellent. Yeah, I like that.
Very nice.
And you'll have more people also joining you. So right now, let's thank you.